Hey guys, welcome to another A-Level Maths revision video. Today we're taking a look at some AS content using the Year 1 textbook. We're taking a look at straight line graphs. So let's take a look at what we've got for this first question here. So from the very first exercise, for this chapter, exercise 2a, question 10. So we're given 3 points, A, B and C, and we're asked to show that these points are collinear. So the clue is kind of in the word. So if you're unsure what it means, so let me just change my pen colour. So, if something has this idea of this element to it, like for example co-workers, they share something in common, right? They work together. So, because of this fact, and the fact that it's linear, what we'd hope to find for collinear is that the points are all on the same line. Okay, so all the points should lie on the same line. Okay, so that's the key idea with this question. So we just need to show that somehow. So how would we do that? Well, the first thing I could think about is working out the gradient between these points, because we can't really do a massive amount of anything else with them. But for example, if I consider the gradient of A to B, so the gradient AB, and I consider the gradient of A to C, so the gradient of AC, between them 2 points, they're going to share a common point between those 2 line segments. So let's have a go at that. And what we should hope is that they share the same gradient. Okay, so gradient of AB. So how do we work that out? Well, if you take the point B, so that's 0, 4a, and I do y2 minus y1, so that's 4a, that's my y2, minus y1, which is 5a. So that's my numerator. My denominator is going to be 0 minus 2a, so that's 0 plus 2a there. And if I work this out, this becomes minus a in the numerator, and then 2a in the denominator, and this cancels to give us minus a half. Okay, so minus a half there. Now let's work out the gradient of AC. So what would that be? So again, same idea, y2, which is a, minus y1, which is minus my 5a here, divided by, whoops, I don't know why I've done it like that. So that's just be a, I'm not quite sure why I'm doing it like that. That's a minus 5a. And then in my denominator, it's going to be 6a minus 2a. Okay, but it's minus 2a, so sorry, that's going to be plus 2a. So I'm not off to a good start. So that's minus 4a in the numerator. And in my denominator, we get 6a plus 2a, giving us AA. So don't make the same mistakes I do. But if you cancel this down here, simplify it, you get minus a half as well. And that's the good news here. We should have hoped to find that these 2 line segments here, so the gradient of AB and the gradient of AC, they are the same gradient. So they share the same gradient. So they share the same gradient. And what we also need to just make clear, and there is a point in common between the 2 line segments. Point in common between the 2 line segments. I don't know if I need that hyphen there, but let's run with it. So there we have it. Okay, so 3 marks for that, just showing that they share the same gradient, and therefore, because they share a common point, they must be basically all on the same line. So that's the first question done there. Let's take a look at the next one now. So we've got a line L, it has gradient 3 and y-intercept 5. And we're told that it has this equation here. So all we've got to do is find A and C. So how would we do this? So it's 2 marks, so we shouldn't expect a massive amount of work. What I would recommend is that you write it in a form that you are confident with. And to get this A and this C, so notice the A is to do with the gradient, and the C is my y-intercept. So a form that we are used to, which gives us this in a nice easy format, is y equals mx plus c. So rearranging this here, we get 2y is equal to ax plus c. And then cancelling down here, we get y equals a over 2 x plus c over 2. Now, we know what the gradient of the y-intercept is. We've been told that at the beginning of the question. So, m for this question is 3, that's our gradient. And the y-intercept is 5. So we can now use this information. Because remember, the a over 2, that corresponds to the gradient. That a over 2 is equal to m. So a over 2 is equal to m. But m is 3, so therefore, a over 2 is equal to 3. And if we solve this, nice linear equation here, dead easy, that gives us a equals 6. Do the same here, so therefore c over 2 is equal to our y-intercept here, so that's equal to 5. And again, just times through by 2. So c is equal to 5 times 2, giving us 10. So a equals 6, and then c equals 10. The next question here, there's a bit more to this question, 6 marks for it, so you know there's going to be a bit more work going on. Now you wouldn't kind of be given this little bit of a hint here, that Edexcel will give you. So you know, kind of just be aware of that. In your exam, you're going to get nothing like this. But it's the point it makes is good. You know, in an exam, more often than not, you will be given a sketch, and usually it's not drawn accurately, but you can use it as a rough guide. So like they say here, what we should expect is that the value of c, as it's below the x-axis here, it should be negative. Okay, so let's have a go at tackling this question. So what we have here is 3 points. We've got A, B, and C. Well, let's just write these down. Right. So now we've got these 3 points here. What we're actually looking to work out is the y-coordinate at C. Well, how can we tackle a problem like this? Well, the first thing we know is that the line through the points A and B is perpendicular to the line through points B and C. So we can't technically, or we can't directly work out from here the gradient of BC, but what we can do is work out the gradient of AB, and then because they're perpendicular, we can then go on to work out the gradient of BC. So let's work out the gradient of AB first. So the gradient of AB, so that's going to be 0 minus 4. So have I done this the wrong way around? No, that's fine. 0 minus 4 over minus 3 minus 0. So that's minus 4 over minus 3, which cancels to give us 4 over 3. Okay, so far everything's okay. So now we've got the gradient of AB, we can simply work out the gradient of BC because we're told that these two lines are perpendicular. So remember, the gradient of BC is simply the negative reciprocal of this. So the reciprocal is 3 over 4 and then times it by minus 1. So that's 3 over 4 and times it by minus 1, we'll just get minus 3 over 4. So now that we've got the gradient of BC, we can just simply work out the equation of the straight line and then just sub in when x is 0. Okay, so using now y minus y1 is equal to m times x minus x1. What would that give us? That's going to give us y minus, so if we use the point minus 3, 0, that's going to be y minus 0 is equal to minus 3 over 4 x minus minus 3, so that's x plus 3. So simplifying this here, we get y equals minus 3 over 4x minus 9 over 4. And all we've got to consider here now is we've done all the hard work. We just need to consider what happens when x is 0, because that's what that point is there. So C, so this is when x equals 0. What do we get for y? Well, using now this equation down here, call it equation 1. So we sub x equals 0 into equation 1, we get y equals minus 3 over 4 times 0, which is just 0, minus 9 over 4. So what we simply get for y is minus 9 over 4. And there we go. So that gets you your 6 marks there. But like it said, good idea is if this was to come out positive, this y value here, we know instantly we've made a mistake, as it should be negative. So, just little things like that, always keep an eye open for them. It will help you through the exam. So this next question now is a question to do with modelling using straight lines and straight line graphs. So there's a few different parts to it, and quite a lot of marks overall for this question. So this is quite a standard exam type question. So let's have a go at taking this step by step. So for part A, all we need to do first is write an equation linking the Fahrenheit F and the Celsius C in the form F equals AC plus B. So in other words, we just want to write this as a linear equation. Well, first what I'm going to do is I'm going to consider the information they've given us. So we've been given two temperatures, or two sets of temperatures here. So in other words, I can write this as two sets of coordinates, so x1, y1, and x2, y2. Okay. So what goes with x1 and y1 and what goes with x2, y2? Doesn't really matter which way you kind of do these, as long as you're consistent with the way they go. So what I mean by that is, for example, so if I say x1 is for the 9 degrees, then the y1 has to be the Fahrenheit for that, so it has to be 48.2. So you can't use, it's not like pick and mix, you can't use the 68 though, it has to be the 48.2 because that's what links them two together. Same again here. So this is now 20 degrees, so that has to be the 68 there. Okay. So now we've got the two sets of coordinates here. Let's see if we can work out some information about it. So instantly, I'm considering working out the gradient. So m is going to be equal to 68 minus 48.2 divided by 20 minus 9. So what will that give us? Well, that'll give us 19.8 divided by 11, which works out as 1.8. So the gradient is 1.8. So what we actually know now is we can update our equation. So f is equal to 1.8c, that should be a capital C, but my handwriting is terrible, plus b. Okay, so now we've got the gradient. We can just simply work out the b here now. So all we've got to do is just sub in a point. So I'm just going to pick the 20 and the 68 rather than picking the 9 and the 48.2, just so I don't have to use decimals. So using now 20, 68, so x2, y2, what we can say then is Fahrenheit 68 is equal to 1.8 times 20, which is the degrees in Celsius, plus b. And if you just work this out now and solve for b, what you should get is b is equal to 32. So therefore now we can write our equation for f. So f is equal to 1.8 c plus 32. And there we have it. So you might sometimes see this as 9 over 5c. Both are absolutely fine. But just so you're aware of that. So 1.8c plus 32 there. So part B just asks us to interpret the values of A and B. So to be able to interpret these values, you need to consider the question in context. So what have we got here? Well, we're talking about temperatures, right? And we're comparing between degrees Celsius and degrees Fahrenheit. And we need to understand how this straight line equation works. So the A, which is our gradient, so A equals 1.8, this represents the increase in Fahrenheit for every one degree increase in Celsius. For every 1 degree increase in Celsius. Okay, so for example, if A had been 2.5, for every 1 degree increase in Celsius, the Fahrenheit temperature goes up 2.5 degrees. So just so you're aware of how that kind of links together. So what does B have to do with anything? Well, B simply, which is equal to 32. So what is that? Well, that's just the Fahrenheit temperature. that's the Fahrenheit temp when Celsius is equal to 0. Okay. Obviously, if you put A equals 0 into there, then you just get F equals B, which is 32 there. So that's our interpretation there of A and B. Part C, we can do this to get at the bottom here with this one, a nice short one. So what it's saying here is that the highest temperature recorded in the UK was 101.3 degrees Fahrenheit. We need to calculate its temperature in Celsius. So all we need to do here is just essentially a substitution. So we're saying 101.3 is equal to 1.8c plus 32. Okay. All we need to do now is literally just solve for c. So it's as easy as that. So I take 32 off both sides. I get, what's that, 69.3. And then just divide 3 by 1.8. And I should get here 38.5 degrees Celsius there. Okay. So there we have it. So just 1 mark for that, because it's essentially just, you know, a basic GCSE substitution question. And then for part D, we need to find the value for which the temperature in Fahrenheit is the same as the temperature in Celsius. So 3 marks for this. So let's consider what we're trying to find here. So if we want the temperature in Fahrenheit to be the same as the temperature in Celsius, what we're essentially looking for here is F equals C, or C equals F, doesn't matter which way you write it. So F equals C. So in other words, I can rewrite my equation here. So F is equal to 1.8F, if C is equal to F, plus 32. Okay, and again, all we need to do is just solve for F here. So this gives me minus 0.8F is equal to 32. Dividing through by minus 0.8 gives us minus 40. Okay, so therefore, minus 40 degrees Fahrenheit is equal to minus 40 degrees Celsius there. Okay, so for 3 marks, that was, you know, quite a nice, easy question. Just got to be aware of that fact there. So that's that question done. Let's take a look at the next couple of questions here. So this question now, we're given 2 points, A and B, and we've got a bit of SIRS mixed in with this one. So what we're asked to show is that the line L meets the x-axis at the point C, which is minus 2, 0. So let's consider our 2 points, 1, 3 root 3, and B, which is 2 plus root 3, 3 plus 4 root 3. Okay. Now, at this point here, and I mean this is kind of true for a lot of these questions, one of the first things you should probably consider, and this is, again, like I said, for most of these questions, consider just working out the gradient. It might prove out to be worthless, but it's, you know, you're always going to get something with it usually. So the gradient of AB, what's that going to be? Well, that's going to be this point here, 3 plus 4 root 3 minus 3 root 3. And then we divide that by this point here minus this one. Okay, so if we simplify here, what would we get? Well, this numerator will just cancel to give me 3 plus the square root of 3, because 4 root 3 minus 3 root 3 just gives us root 3. We divide this by 2 plus root 3 minus 1, so in other words, just 1 plus root 3. So at this stage here, this gradient's kind of worthless, we don't know much about it. So, because we've got a root in the denominator, one good little trick here we can do is rationalise. So, rationalise here. So rationalise this. So remember, you times through by the conjugate. So we times through by 1 minus root 3, because that's the conjugate of 1 plus root 3. So, expanding this now, I get 3, I get minus 2 root 3, And I'm going to get root 3 times minus root 3 being minus 3. In my denominator, this is the difference of two squares, so you can just do 1 times 1 and then root 3 times minus root 3. So that's 1 minus 3. So if we simplify this now, the 3's will cancel in the numerator, so I'm just going to get minus 2 root 3 divided by 1 minus 3, which is minus 2, and then the minus 2's are just going to cancel here just to give us root 3. Okay, so now we have the gradient. Well, let's consider one of the points, because now we can work out the equation of the straight line. Because we've got the gradient, we've got two sets of coordinates here. Doesn't matter which one you sub it into, but I'm going to pick point A because, you know, there's only one square root in it. So making life easier, so all we need to do now is sub A into y minus y1 equal to m lots of x minus x1. So y minus 3 root 3 is equal to root 3, because that's my m here, times x minus 1. So if we simplify this, I get y minus 3 root 3 is equal to root 3x minus root 3. Okay. So here, what can I do? Well, I can add 3 root 3 to both sides, to just get in terms of y. So minus root 3 plus 3 root 3, I just get 2 lots of root 3 here. So plus 2 root 3. So what we actually want to show is that L meets the x-axis at the point minus 2, 0. So for that to be the case, in other words, y must be equal to 0. So if we take it up here now, if y equals 0, what I'm going to get then is root 3x is equal, so taking this to this side now where it's equal to 0, so this is going to be equal to minus 2 root 3. Now if you divide both sides by root 3, all you get left with is x equals minus 2, which is what they've got here. So therefore L meets the x-axis at minus 2, 0. Because remember, when it crosses the x-axis, that's when y is 0. And then just solving this here to get x, so we can see that it crosses there. Okay, that's a tick, believe it or not. So there we go. So 5 marks for that. So hopefully that's okay. Make sure you're just confident with surds. And now we move on to the very last question here, from review exercise 2, question 6. So we're given two lines here. We've got y equals 2x and 5y plus x minus 33 is equal to 0. So if I just write this down quickly. So we're told that they intersect at the point P. So at some point, what we're probably going to have to do here is work out that coordinate of intersection. And we want to find the distance of that point from the origin O. So yeah, we need to work out where they intersect. So a couple of different ways you can do that. You can do it graphically. You could do it using substitution, for example. So I'm going to take substitution for this example here. So how would I do substitution for this one? Well, if y equals 2x, if I can rearrange this equation now in terms of y, if they're both equal to y, then the equations must be equal to each other. So let's get this in the form y equals mx plus c. So 5y is equal to 33 minus x, just subtracting x and adding 33 to both sides here. So y, simply just divide through by 5. Like so. So this is actually in the form y equals mx plus c. I've just got it over a common denominator. What this would simplify to is minus x over 5, or minus a fifth x, and then 33 over 5. So we've got these both in terms of y. So in other words, what we can say is that 2x is equal to 33 minus x divided by 5. So here now, all I need to do is solve for x, then we can work out y, and then we can work out our distance using the distance formula. So 2x times 5 here, just get rid of this denominator of 5. So that's 10x, times across by 5. equals to 33 minus x. Add x to both sides now, so we get 11x is equal to 33. And then divide both sides by 11. Nice and easy. We get x equals 3. So now we've got x, we can simply work out y. You can substitute in either this one here, equation 1, or equation 2 here. Doesn't matter. The easy one would just be obviously equation 1. So y equal to 2 times x, which is 3. So y is 6. So at this point P, that's 3, 6. And we're considering the distance to this point from the origin. So how do we do that? Well, we need the distance. So that's going to be equal now to the square root of y2 minus y1 squared plus x2 minus x1 squared. Okay, so my y2 in this case would be 6, my y1 would be 0, my x2 would be 3, my x1 would be 0, because we're comparing this to the origin 0, 0. Okay, so if we apply this formula, d is going to be equal to the square root of 6 minus 0 squared plus 3 minus 0 squared. So that's going to be equal now to the square root of 36 plus 9. So 6 squared is 36, 3 squared is 9. So this is equal to the square root of 45. And at this point here, if we give it in its simplest form, we can split this up now into 2 square roots, or 2/3. So this is root 9, root 5, and root 9 we know is just simply 3. So we can write this as 3 root 5. So there we have it. So that's the distance out of the length. So that brings us to the end of this video. I hope this has helped. If there's any issues, if you notice any mistakes, please just let me know down in the comments below.